Welcome to Forging the Future, Decarbonizing the Steel Industry, a Hatch podcast series. I'm your host, Takshi Sachdeva, and invite you to join us on a journey through the challenges and innovations in iron and steel production. Discover how Hatch's century of expertise is shaping a sustainable future for the steel industry. Stay tuned as experts from Hatch share their insights on technology, market dynamics, and the path to decarbonization. In today's episode, we'll be talking about synergies between nuclear power and steelmaking. We're joined today by Richard MacRosty and Herbert Lamb. I'd like to start with a quick introduction, Herbert and Richard, sharing with our audience your career at Hatch and perhaps focusing on some of your past experiences today.
Sure, thanks, Takshi. So, given that the podcast is around steelmaking and that I'll start off with my relevant experience, which was when I first got into this area. So maybe 25 years ago, I actually started at grad school and did my PhD around electric furnaces, and then moved straight on to Hatch thereafter, and have spent my career working in and around furnaces over the last 20 odd years. And I'm now the global director of our power and controls technologies team. So I look after a group of specialized individuals who have background in power quality, controls, and automation. And so, thank you. Very excited to be sitting down with you and Herbert today, having this conversation.
Excited to have you here.
And I started my career at Hatch in the thermal power group. So I've worked on a lot of combined cycle, coal-fired power plants, specifically for utility applications, also for industrial cogeneration and power generation applications. I've actually worked on some power plants for iron and steel facilities. And then within the last 5 years, I've decided to make the switch over to nuclear power. So still working on the same systems. I'm a mechanical engineer by trade, work still in steam turbines, feed water heaters, but now just with a different heat source instead of a fossil fuel source. And I'm currently the regional manager for a nuclear group in the U.S.
What made you make the switch to nuclear?
We're at a very exciting time in the industry, the nuclear industry. There's a lot of new technologies coming to the forefront, and it's unlocking a lot more opportunities than which was been in the past for bringing nuclear to much more nuclear in the world and much more nuclear for industrial applications as well.
No, thanks for sharing those details. We understand that nuclear is green or carbon emissions free. I'd like to shift your focus back to the steelmaking industry's move towards electric steelmaking in the future, which will require access to hundreds of megawatts of clean power. And considering all the power we have comes mostly from fossil fuel sources, in your opinion, what are some reliable and economic sources to generate this emission-free electricity?
So for clean power, you pretty much have very limited options in terms of what's available for technology options. For steelmaking plant, we're talking about hundreds of megawatts. We're not talking about a small quantity of megawatts, which creates a big scale problem for a lot of different technologies like solar and wind facilities. Like getting to the hundreds of megawatt scales requires a long land mass. But in addition to that, there's also a big issue with just the relying on weather patterns that could be very intermittent power generation source. The only reliable and continuous power supply is nuclear power, which is a carbon-free source of power that can be deployed for steelmaking, and a kind of perfect marriage between being able to provide a reliable and clean power source that is able to meet the scale and demands of a steelmaking application.
Yeah, maybe another point is in the steel industry, there is a big demand, but specifically EAFs, it's a very challenging electrical load. So as Herbert was saying, you have the extreme demand, but the variability that you see. So both in terms of quantities as you go through the operation and just the dynamic variability inherent in the process. And the one way we can counteract that is with rotational inertia. It's often the word that's sort of thrown around in the industry that you get from turbine generators. So these are, the hydro, coal, and nuclear generators that you'd have. And that helps the electric system drive through all these little bumps that we see coming from furnace operations. Ideally, you want to match the supply and the demand and keep it like that. So when you have a furnace operation, which is moving the power level up and down, and then these high-speed variations, that provides a lot of challenge. If you contrast that to renewables, which generally connect through inverters, they don't have that rotational inertia. So you get high penetration systems, and essentially you start losing that capability in your grid. Additionally, as Herbert said, the intermittency of solar and wind, that takes away from that consistent source. So really, nuclear does offer some unique opportunities if you're looking for a carbon-free generation.
Thanks for sharing those details. We understand that nuclear is green or carbon emissions free. How is the market perceiving it today?
So nuclear has traditionally been lumped into categories of investments that a lot of pension funds and other investment funds have refused to invest in. But that underpinning is an old philosophy that's changing today. There's been a number of companies been issuing green bonds backing nuclear power, and it's been seen as a true solution for a emission-free decarbonized electricity grid. So when we look at today, there's been a significant shift in how people perceive nuclear. A lot of people have this old image of nuclear power plants of 3 Mile Island or Chernobyl. But if you look actually at the track record of nuclear, it's not, those are extreme outliers, and we have significant long history of safe operating plants today and able to provide a significant source of green carbon-free electricity for the grid around the world.
Yeah, I think fundamentally the technology's changed, so it actually is intrinsically safe in contrast to previous.
Yeah, no, thanks for touching on that. Can you perhaps elaborate more on the safety aspect of nuclear power?
Been continually proved it's the safest form of electricity generation. There's been a number of studies looking at the deaths per 100,000 megawatt hours generated, and nuclear always ranks at the lowest of that tier. So nuclear is a safe technology, and a lot of the misconceptions around nuclear power is around misunderstanding of the perceptions and some of the safety systems that are involved within a nuclear power plant as well. Every technology has its own pros and cons. And we at Hatch, we look at every technology, weigh the benefits, weigh the drawbacks, and we work with our clients to understand what their risk profile and risk acceptance of it is. And in addition, we also look and deploy and work on projects that align with our own corporate values as well.
When we talk about nuclear, the default image we get in our heads is a multi-gigawatt facility with large capital investments. If you look at steel being a highly competitive industry, how can nuclear perhaps fit in the scale of power demand required for steel making?
So the image that you have in your mind is really of what I would call conventional nuclear. If plants were built in the 70s, 80s, and where we're looking into the nuclear industry today is really significantly shifted in how we think about the size of power plants and what's actually a cost-effective approach to building new power plants. So we're looking toward what we call small modular reactors. There's no official definition, but a lot of data points that people anchor toward to is 300 megawatts electric for the SMR. So we're actively working on developing SMR technology today. Those are bringing new opportunities to better match it for new applications such as steelmaking. But also we're able to deploy them much more readily because the capital cost of a power plant significantly reduces, and we're able to get reps in being able to deploy these reactors. So you're able to bring your experience of building reactors and bring them to new power plants. Because if you look at a large gigawatt scale, we're always making these monster projects that end up being a first of a kind project in its own each time. So you're not getting the cost curves that drive the cost down for future power plant deployments. The new SMRs have technologies that make them inherently safe. So where they can be truly walk away safe if something that does go wrong, it doesn't require any operator intervention. Like we're using natural circulation to remove decay heat from the reactor. So we don't need to have an active cooling system to remove the heat from the reactor as it shuts down. So that provides benefits to reducing the amount of safety systems involved and also enhancing the safety of the reactors that we have.
So you touched upon SMRs. I'd like to know, where is the technology in today's world?
There's a lot of different approaches that are being undertaken to developing SMR. So we have some reactor vendors who are looking at taking existing technology and downscaling them, but also improving them. So we have a current generation, which we call Generation 3, which is the current generation of reactors online. And those are based on light water technology. So that's all the technology that we have currently installed, like the pressurized water reactor, boiling water reactors that you'll see when you go out and see, like, those are the reactors that we currently have installed today. But we also have a new wave of SMRs that are being developed. They're based on advanced reactor designs that take new coolants, take new fuel types that provide new benefits to unlocking some new applications such as industrial heat applications, and those are what we call Gen IV reactors. So those are the technologies that are also pushing the boundaries of materials, fuel types, and just also our design and construction methodologies that we have in today's world.
Shifting our focus back to tying nuclear in with electric steel making, do you see any specific challenges with that?
Yeah, and I think, as I alluded to earlier, one of the most challenging processes to operate electrically is the electric arc furnace EAF, and the reasons are for a couple. Well, there's two good reasons. So one is just how you operate them in batches, which in the industry they're known as heats, and you generally start off with no power, turn the power on, and this is the bore down phase where you're trying to increase power as fast as you can, and you're drawing an arc on cold scrap, and that is electrically a very challenging process. A lot of dynamics, causes all sorts of havoc in the electrical system and can potentially be passed up to the grid. But as you progress through the heat, you then get down to a molten bath, and where you're refining, it's a much more smooth power load. But then you ultimately tap the furnace and turn the power off. And so the combination of those big swings and the dynamic portion, particularly during the bore down, is where it is very challenging. And so, this idea of rotational inertia, which we spoke about earlier, becomes more prevalent.
Thanks, Richard, for explaining some of the challenges. I think the EAF load is particularly creates a significant challenge for nuclear reactors as well. I think given the large variations, like nuclear in itself is not a type of generation resource that can ramp quickly up and down. So there's some technology solutions that we have to look at to balance a nuclear power plant if it was directly connected and islanded with a EAF. Given just some of the inherent physics inside a reactor, ramping quickly just can create an issue within the reactor reactivity itself. So balancing the needs of the EAF with the actual generation source is a very important topic that we need to be carefully evaluate for any combined EAF and nuclear power plant.
No, exactly. And I think often it requires a bespoke solution. And so something that we do in a lot of our projects is really trying to understand what the unique conditions are around the grid, around the load, and what's being used, because, it could be anything from, a dump resistor, which is an inefficient use of that power, to, where can you use that power when you, as an alternative. So these are kind of the solutions that all need to be factored in considering how to best match up your generation with your load.
Yeah. And any islanded operation, like if you do have access to a clean grid or any kind of grid operation to support the operation of the EAF with the nuclear power plant, should also be evaluated. Like there's always an evaluation in terms of what are the connection costs, how does that impact your operations, and what are the operating costs associated with using the grid connection in conjunction with the SMR or nuclear power plant on site as well.
Where do you see this combo of nuclear and steelmaking work geographically in the world?
So there's significant complexities in operating a nuclear power plant in any country. So the safest and easiest place to start is always countries that already have nuclear power plants and steelmaking together, because there's a big infrastructure that needs to take for establish the regulatory framework in the country, and then also establish the supply chain and workforce, et cetera, within the country. So we've seen a significant interest in the U.S. on this topic, and then also in other jurisdictions and Europe and elsewhere around the world on looking at these, bring the marriage of these two different types of technologies together.
Yeah, I think if you're trying to reduce the carbon load, certainly nuclear is an obvious one. As we spoke about earlier, I think renewables there's a lot of challenges around supplying power to a furnace, for example. So yeah, replacing existing carbon sources, new productivity or capability would certainly be areas where you'd be looking to go.
Yeah. In fact, as you say that, when we try to increase your renewable penetration, nuclear actually provides a good option to support additional renewable generation in your grid as well. So every time you install a nuclear grid, you provide more rotational inertia on the grid, which enables much more renewables. When I mean that, I mean like wind and solar power plants on your grid as well.
So we understand the different challenges that come with this integration of nuclear with steelmaking. From Hatch's perspective, how would you go about checking off all these different elements and challenges?
So, I mean, I think the first step with any project, and especially undertaking a magnitude of combining nuclear and steelmaking, and we work with our clients to really establish and understand the business case for bringing nuclear power on and understanding why it makes sense for their operations. We look at the alternative options of power, if it's grid supply, remember our own power generation, just really build the case around why nuclear is the best option for them. I think we'll look at all the different scenarios of what the energy independence that nuclear would give for them, so they're not having to deal with curtailments, other operations, being able to have their own power and a secure, reliable power source that's economical for their operation for the life of their facility as well, and build that into a business case and start planning the project and making sure that aligns with their own business objectives.
I'm curious to know what makes now the right time to be jumping into this.
So the current developments within the reactor nuclear industry creates a perfect synergy for steelmaking, because if you look in the past, if we are trying to build a nuclear power plant, you're going to be building something that's like 3,000, 4,000 megawatts, which doesn't really make a lot of sense for an individual steelmaking facility. And now we're at the point where we're reshifting the paradigm of how we think about size in the industry and focusing on smaller plants. So an SMR or something that's better match for a steelmaking plant, and those are being actively developed and being deployed. Like one of the first SMRs in the world is actually going to be deployed here in Ontario.
Yeah, and I think there's also push factors. So Herbert spoke about the sort of pull factors to using nuclear, but obviously we're trying to do less with fossil fuels. So, that, and then the other point we made around renewables, you can have more renewables if you have the rotating inertia, which traditionally has come either through hydro, which is limited, or fossil fuels. So I think that's the opportunity too.
Oh, thank you. Thank you both for a very interesting conversation today and talking about the integration of steel industry with nuclear power. Would you like to end with a key message for our audience today? Any key takeaways you'd like to focus on?
I think if you're looking for any scalable and reliable green electricity source, you don't really have any option except to consider nuclear. We can look at the other options that are on the table, but nuclear is the most economical and reliable solution that's available to a steelmaking operation.
Richard?
Yeah, I think I'll target my message maybe to a different audience, which would be, the people who are thinking of getting into engineering. It's such an exciting time to be involved. There's so much new things happening. We've got a lot of challenges, and I think it's engineers who get the opportunity to step up and really make a big impact. So that'd be my message.
Thank you. Thank you for joining us today.
Thank you for joining us on Forging the Future, Decarbonizing the Steel Industry, where we navigate the complexities of iron and steel. We hope today's episode has provided you with valuable insights into the sustainable transformation of the industry. Remember, the path to decarbonization is a collaborative effort, and every step counts towards a greener future. I am your host, Takshi Sachdeva, and along with the entire team at Hatch, we appreciate your engagement and curiosity.